Alright, page 1. Determine whether the given point is a solution. So here's the point. Here are the two equations. All you need to do is see if the point works for both. So let's just take a look at this right now. 3 times 1, that would be 3, right? Minus 2 times a minus 1 would actually be plus 2. And sure enough, that equals 5, so that looks good. Down here, 2 times 1 is 2. Negative 1 times 5 is a minus 5. And sure enough, that equals negative 3. So that is a yes. That's going to be a solution. Alright, come down here, next problem. Same kind of deal. Plug it in, see if it makes sense. So negative 2 times 4, that's going to give me a negative 8. Negative 3 times the minus 3 is going to give me plus 9. And we can stop right there, because 1 is not greater than 1. That doesn't make sense. It would have to be greater than or equal to, then it could work, but that's not. It's just greater than. 1 is not greater than 1, so that is going to be a no on that one. Alright, next question. Which system is easiest to solve by substitution? Well, you just look at the one that has a variable with no number attached to it, because those are the easiest to substitute for, because you don't have to multiply or divide by anything. And if I look at B right there, I've got a y all by itself. So if I had to solve for y, it would be pretty easy, and so I'm going to say B is the best choice for solving by substitution. Alright, so number 4. Choose the best initial step in solving the system by substitution. Well, again, I'm going to look at this equation up here because y is already all by itself. And all I have to do to solve for y is just subtract 3x from both sides. So I'm going to solve the first equation for y. That would be the best initial step. So we got another B. Alright, and now number 5. When the linear equations and a system of equations have different slopes, key words right there, and the same y-intercepts, the system is said to be, okay, so hold on, right off the bat. If they have different slopes, it can't be inconsistent. Inconsistent is when you have parallel lines. At the same time, it can't be consistent dependent, because consistent dependent has the same slope. So if there's different slopes, it has to be consistent independent. Those lines are going to intersect at some point. Alright, going on to the next side, page 1. Number 6. Let's see if I can get this a little bit focused a little bit better here. Hold on just a second. Seems like it's getting a little blurry. There we go. Alright. When solving a system of linear equation produces a false statement, such as 1 equals 2, the system is said to be, that's going to be inconsistent. That means there's no solution. Because 1 does not equal 2, so it doesn't make sense. Okay. Determine the multipliers needed to eliminate the x terms. So we want to eliminate these guys. In the following system, do not solve. So I do not have to solve. Okay, I won't. So I've got two numbers here. I've got 3 and negative 5. And basically, the question I'm asked is, what number can I divide by both of those numbers? And I want it to be as small as possible. So I think 5 can't divide it by 3. What if I multiply it by 2? I get 10. Can't divide by 3. But if I multiply it by 3, I get 15. Yeah, I can divide 15 by 5. I can divide 3 by 5. So 15 is the number I'm going to want. So what do I multiply the top one by to get 15? Well, I multiply by 5. And then on the bottom here, what do I multiply to get 15? I'm going to multiply by 3. So I'm going to do the top equation times 5, bottom equation times 3. Alright, we get to do some graphing. Let me pull out my ruler here. Pull it out yet. Y equals 2x minus 6. So I always start with, when it's in slope-intercept form, I always start with the y-intercept, minus 6. So I'm going to go down 6. Slope is 2. So I'm going up 2 over 1. I'm going to put a couple on here just to make my line a little more accurate, hopefully. Okay. So there's that line. Alright, and then we've got negative 3x plus 4. Again, I'm going to start with the y-intercept. You just go up 4, and then down 3 over 1. And I can see where they're going to cross, right there. At that point, which looks like it is 2, negative 2. Alright, that's all we have to do for that one. Last one on page 1, number 9. Again, I'll do this one first. Start with the y-intercept. It's minus 6, just like the last problem, so I go down 6. Slope this time is 3, so that's up 3 over 1. Again, I'll plot a couple of points there, just for kicks. This will be a solid line. This here I have a little work to do because it's not slope-intercept form, but not much. I mean, I just need to move the x's over to the right side. So I subtract 2x plus 3. So my y-intercept is 3 now. Slope is minus 2. So I'm going down 2 over 1. And this line is going to be a dotted line. It's not going to be a solid line. Okay. So the last question I need to ask is, where am I going to shade? Well, if I look at the top one, it's y is less than or equal to. So that means it has to be below this line. And I like that because it automatically tells me that it has to be either this region or that region. Those are my only two options now. It has to be here or here. So I look at the second equation. This one is y is greater than, so that needs to be above this line, so it has to be this region right here. Now again, it's not a bad idea, if you're not sure that you've shaded the region right, to pick a point, like pick a point right there, 0.30, and plug it in and see if it works. And sure enough, you know, if I did that, if I plugged in 3 for x here, 0 for y, and 3 for x, I would get negative 6 plus 3, and sure enough, 0 is greater than negative 3. It works. And then I could do the same thing up here, and it would also work. If I plugged in a 0 for y, a 3 for x, I would get 9 minus 6 is 3. 3 is bigger than 0. So there's page 1.